students, welcome to my class. In this video we are going to be discussing about speed of efflux or Torricelli's law. That related problems we are going to be discussing. Here the question is given as water contained in a tank flows through an orifice of diameter 2 cm under a constant pressure difference of 10 cm of water column is given. Here it's given as a water tank is given, and here an orifice it is given as here at 2 cm, and here the liquid it will be at a height of 10 cm water column is given. This will be at a height of 10 cm water column is given, and here the rate of flow of water through the orifice they are asking. So here the rate of flow of water. So here you will be taken as according to the Bernoulli's theorem. Here we can write it as there's a pressure you can write as P naught, and here if this area will be higher in the sense this will be A1 suppose you are taking, and this will be the A2, and this pressure also will be taken as P naught. With what velocity is coming outside, first we need to calculate. This is V2 and this will be V1 you are taking. If here you will be getting as A1 is much greater than A2, then we can say A1 is much greater than A2, then we can say V1 is much less than V2 you are taking. That is approximately you can take as V1 value will be 0 you are taking. Then you just apply the Bernoulli's principle according to Bernoulli's theorem. Here you can take on top surface, here we can write it as this is the Bernoulli's theorem. What it is revealing, sum of the pressure energy plus potential energy plus kinetic energy per unit volume, which will be remains constant will be getting. First let us talk about the top surface. Here we can write it as P naught plus rho into G into H plus on the topmost side here the velocity will be getting as 0 will be getting rho into V square plus, and here next we can talk about this will be influenced by an atmospheric pressure this side. This is P naught plus rho into G into this is at the base you are taking, this height will be 0 plus half into rho into V2 square you are getting. So P naught gets cancelled. When you are simplifying these values, here will be getting as V equal to, you will be taken square root of 2G H will be getting. So this one will be calling as speed of flux will be called. So with what velocity the fluid is coming outside, that will be speed of flux will be called. But the question they are asking us the rate of flow of water through the orifice. The rate of flow of water means here or else we can take volume of the fluid which is leaving from the orifice, which will be equal to V equal to, you can write it as A into V according to the equation of continuity. Area in the sense here you can write as pi r square into will be taken as velocity of a flux. Just now we have calculated as square root of 2gh, which will be equal to pi in the sense here you can put the value 3.14 into radius is given as here diameter is 2 cm, then radius you can take as radius value you can take as 1 cm. 1 cm square means 10 power minus 4 meter square into square root of 2 into G in the sense 9.8 into you can take as H value 10 cm of water column, 10 into you can take as 10 power minus 2. When you are simplifying this value, here we will be getting as this is 3.14 into 10 power minus 4 into you can write it as this value you are getting as 1.4. So when you are simplifying this value, therefore volume of the fluid or the rate of flow of water through the orifice is V equal to, here you are getting as 4.4 into, when you are multiplying these values, into 10 power minus 4 you are getting this one, you can write it as 440 cubic centimeter per second you can write. So third one is the correct answer. Look at the next question. An orifice of area 10 square millimeter is made at the bottom of the vessel containing water. Area of the orifice is given as A equal to 10 square millimeter, means 10 millimeter square which is nothing but 10 into you can take as 10 power minus 6 meter square you can take. So 1 millimeter equal to you can write it as 1 millimeter equals to 10 power minus 3 meter you can take. So here vessel containing the water to a height of 10 meter above the orifice. Here it's given. This is here the water it's given. Orifice here it is given as 10 meter above the orifice containing water. Here it's an orifice is given, and here the liquid is going to be coming out, and here it's given as this is at 10 centimeter. The bottom of the vessel containing water at a height of 10 meter above the orifice. Or else here you can take, sorry. So area is given as 10 square millimeter is made at the bottom of the vessel containing water at a height of 10 meter above the orifice. What is the force on the vessel? So here here you can take. This is here at 10 meter above the orifice it's given, water containing to a height of 10 meter. Now the liquid is going to be coming outside. Now here what is the force on the vessel they are asking. So force exerted by this liquid is F equals to, here you can write it as it's nothing but dP by dt. So momentum of the fluid which is leaving from the orifices per second is nothing but we can write it as mass into velocity you are taking, and here mass into velocity by time you are taking, m into v by dt you can take. Mass in the sense here you can take as volume into density into you can take as velocity. Volume of the fluid which is leaving in the sense area A into length. Length is nothing but distance covered by the fluid is nothing but velocity into you can take as dt time into you can take as density into v you can take. So here this is by dt you can talk, and here also dt you can take. Dt gets cancelled. Here you can write it as force on the vessel is, force on the vessel the formula will be getting as A into rho into v square you are getting. So now you have to substitute the values. F equals to A into rho into v square. Area it's given as 10 square millimeter. 10 into 1 square millimeter is 10 power minus 6 meter square into density of the water value is 10 power 3. So with what speed it's coming outside in the sense here you can take the square root of 2gh you will be getting. H is nothing but height, right? It's a very important, students. So vessel, in a vessel the water is containing at a height of 10 meter above the orifice. You need to consider the H value will be above the orifice, how much height will be there, that H value here we need to substitute. This is here v square it is talking, then square you have to take, then you have to simplify this one. Here 10 power 4 and here 10 power minus 6, here it becomes 10 power minus 2, and here you can take 10 power minus 2 into 2 into 9.8 into square and root gets cancelled into you can take as height will be 10 meter it's given, so that will be getting as 19.6 into 10 power minus 1 you are writing. So here this value will be 1.96 newtons you are getting. So third one is the correct answer. Look at the next question. A large water tank has a hole in its wall near the bottom. The water level above the hole is 4.9 meter. Here a large water tank is given. So near the bottom a hole you are going to be placing. The water level above the hole is here 4.9 meter it's given. So this here the hole will be at 4.9 meter it's given, and now the horizontal distance from the hole at which the water touches the ground. Here it's given as
and if the bottom of the water tank is 4.9 meter above the ground, it's given. So here again, here the bottom of the water tank, here it will be again, here it will be 4.9 meter above the ground, it's given. So here this is the scenario. Here now the level water, it's going to be coming outside. Now here we just calculate the horizontal distance is nothing but range we need to calculate. Now here first you need to calculate with what velocity the liquid is coming outside. That is nothing but speed of flux will be calling V equal to the formula square root of 2gh. H is nothing but height above the orifice we can take, that is 2gh. Then time of fall in the sense here will be getting as in what time interval it's reaching the ground in the sense t equals we can take as square root of 2h by g. Here the height is nothing but this height alone you have to consider, time of fall height 2h by g. Both the heights is given as 4.9 meter. Then here horizontal distance is nothing but range. Range formula, it's nothing but distance. You can take as speed of efflux into time of descent you can take, that is square root of 2gh into, you can get it as time of descent is 2h by g you can take. Here one gg gets cancelled. Here you can get it as, this is 2 into 2 will be getting as 4. So you can take it as 2 under root, or 2 into h square you can take it as cancel, square and root, it becomes 2h. Therefore r equals to, here will be getting as 2 into height value will be getting as 4.9 meter, which will be equivalent to 9.8 meter will be getting. So 9.8 meter is the correct answer. Look at the next question. A water tank which is on the ground has an arrangement to maintain a constant water level of the depth is given as 60 centimeter through a hole on its vertical wall at a depth of 20 centimeter from the free surface water. It comes out and reaches the ground at a certain distance. To have the same horizontal range, another hole can be made at a depth of. Here just look at student. Here a water tank it was given. So now you are filling the water tank up to a height h, you are filling the liquid. Up to a height h you are filling the liquid, this is height h you can take. Here you are taking a hole, on a vertical wall at a depth of 20 centimeter from the free surface of the water. From the free surface of the water, here you will be having one hole will be there, and this is at what distance is given as 20 centimeter it was given, and the liquid is going to be coming outside like this. And then the next case, here it is given as to have the same horizontal range, so range should be same. Then here another hole can be made at a depth of, here I am just placing one more hole like here, and here this one also will be having the same range, means horizontal distance covered by the fluid will be same. So here we need to calculate at what depth we need to dock. This is at what depth we need to dock from the surface. So this is a 20 centimeter height is given. So through a hole, it's a vertical wall at a depth of 20 centimeter from the surface of the water comes out. Here you just be remembered, if suppose here you are taking a simple concept. Here if this height it will be at a h1 height in the sense, here if it is here from the bottom, if it is at a height of h2 in the sense, here you can calculate to get the range will be same, to be same range. If two holes when you are keeping, the simple technique you have to apply students, h equals to you can take as h1 plus h2 you can take. So here h in the sense total height you can take, h1 here will be getting as, now it was given already, h2 value you just calculate, then h2 which will be equal to, you will be taken as capital H minus h1 you can take, that is
60 minus, here we'll be getting as 20 centimeter, which is nothing but here you can take as 40 centimeter you can take. Look at the next question, student. A tank full of water has a small hole at its bottom. If 1/4 of the tank is emptied in t1 seconds and the remaining 3/4 of the tank is emptied in t2 seconds, then the ratio of t1 by t2 they are asking. Here you just look at the students. Here this is the concept. Here if you are taking the water in a tank and this is the water height you can take initially, and you are filling up to a height of h. Now here an orifice here it will be there at the bottom. Now the liquid is going to be expelling outside. If you want to decrease the water level from height h to this height, this is the height you can take. This height you have to consider as h dash you have to consider. Here to here it is h dash you have to consider. The time to decrease the water level from h height to h dash height means there's a formula will be there for that time. This is here we will be getting as a by a naught into 2 root over 2 by g into, you can write it as square root of h minus h dash. Capital A is nothing but area of the surface of the liquid you are taking, and a naught is nothing but area of the orifice you are taking. Now here let us talk about here the ratios of the T1 by T2 they are asking. Initially you are decreasing the water level, 1/4 of the tank you are emptying. Means here you can take as T1 is here directly proportional to, here you have to consider as root of h minus, you can take as h dash, you can take all the quantities you can make as constant. Then T is directly proportional to, you can take as root over h minus h dash. Then T1 if you are calculating, T1 is directly proportional to root over h minus. So 1/4 of the tank you are emptying in this sense, remaining how much will be getting? It's nothing but will be getting as 3/4 will be having. So from the ground you can talk about the height. So 1/4 it is emptied in this sense, here remaining it will be h dash is nothing but here will be getting as 3/4 of the h. Whereas in the second case here we will be getting as T2 and remaining 3/4 of the tank is emptied, means here this height will be getting as T2 is directly proportional to. So here the height is decreasing from 3/4 of the height to it is emptied, means here the height value will be 0. So here T1 values you know, T2 values you know, you just take the ratios. Therefore T1 by T2 which will be equal to, this is root h minus 3h by 4 under root by, here you can get it as root over 3h by 4 minus 0 you can take. Root h if we are taking common, here we will be getting as, this becomes root over 4 you can take as 1 by 2. So here 1 minus root 3 by 2 you can take by, again root h when you are taking common, here you can get it as root 3 by 2 you are getting. So when you are simplifying this thing, here root h you have to cancel. Root h when you are cancelling, here this becomes T1 by T2 which will be equal to, this is 2 minus root 3 by 2 into, you can write it as 2 by root 3 you are getting. So 2 gets cancelled. Here the thing you will be getting as 2 minus root 3 by root 3 you will be getting. So when you are taking the LCM, here it becomes root 2 by root 3 minus 1 will be getting. So this will be the ratios of the time values. Now look at the next question. A large tank filled with the water, it's given as to a height h is to be emptied through a small hole at the bottom. The ratios of the time taken for the level to fall from h to h by 2 and h by 2 to 0 they are asking. Like above question students, time of fall, time to decrease the water level from one height to the another height is T equals to, there's a formula a by a naught into square root of 2 by g into, you can take as root over h minus h dash.
H dash in the sense decrease of the water level from the ground you can take. Now here you can substitute, then T is directly proportional to, you can write it as root H minus root H dash you can take. Then initial time you are taking, time taken to decrease the water level from H to H by 2 you can talk first. That means here T1 is directly proportional to from H height to H by 2 height you can take. This is the T1 value. Whereas T2 value you can write it as you are decreasing the water level from height H by 2 to emptied, means 0 you are taking. Now you can take the ratio students, T1 by T2 which will be equal to, here when you are taking common here root H, if you are taking common it's 1 minus 1 by root 2. This is first equation you have to take, and second equation you can take, and here also when you are taking this is root over H by root 2 you can take. Root H gets cancelled, this becomes root 2 minus 1 by root 2 into 1 by root 2 you can take as root 2 by 1. So here times ratio you will be getting as T1 by T2, it's T1 by T2 you will be getting as, this is root 2 minus 1 by root 2 minus 1 you are getting. So this will be the ratios of the time. Look at the next question students. A large open tank has two holes in the wall. One is square hole and the second one is given as side L at a depth Y from the top it's given. So here it's given as a large tank it's given, has two holes in the wall. One is square hole of side L. So here it's given as one hole is given as square hole, it's given like this. The side length it's given as L is given at a depth Y from the top surface. Here you can take this hole will be at a depth of, here it's given as Y it's given. This is Y is given from the top, and the other one is a circular hole of radius R at a depth 4y from the top. Here it's given as one more hole it's given, it's a circular hole it's given, it is at what distance here means, here it is given as 4y distance is given. This is at 4y distance is given from the top. When the tank is completely filled with the water, the quantities of the water flowing out per second from both the holes are same. So means quantity of the water which is coming outside, so the quantity here which is coming outside and the quantity of water which is coming outside of both the holes will be same is given. Then R value they are asking, radius of this hole they are asking. Here you can take volume of the fluid which is leaving from the square type of hole, if its side length is given as L. So that volume which will be equal to here volume of the fluid which is leaving from the top hole and from the bottom hole, that means here circular hole will be same it's given. According to equation of continuity you can take as V1 which will be equal to volume of the liquid which is flowing per second is V1 equal to, here you can write it as A1 V1 which will be equal to, you can take as A2 V2 you can take. Area of the square hole you are take as L square. V1 in the sense with what speed it's coming outside, in the sense speed of efflux you can take. Speed of efflux is nothing but a formula, V equal to square root of 2gh. H is nothing but height above the orifice you can take. That's nothing but you can take as 2g into you can take as y distance under root, which will be equal to area of the circular hole you can take. That's nothing but you can write it as pi r square into with what speed the fluid is coming outside, in the sense it's a speed of efflux 2g into, here you can take as this is 4y distance height you can take above the surface. Now here you can simplify this one. Here this side here 2g and this side 2g gets cancelled. This side here L square and root 2 also you have to cancel. Here L square which will be equal to this side y also you have to cancel. L square which will be equal to, you have taken as pi r square into, here square root of 4 will be there, that you can take as 2 you can take. That means r square equals, here what you can write, r square is nothing but here you have taken as L square by 2 pi. So then r equals, here will be taken as L by square, you have to take this side, it becomes the square root. So here we will be getting as r equal to L by root 2 pi you will be getting. So this will be the correct answer. Now look at the next question. A water tank is given, has a small orifice of area 1 millimeter square in a vertical side. It is 5 meter below the surface of the level of the water. Here a water tank is given and here it's filled with the liquid, and here an orifice, here it will be there. It is 5 meter below the surface of the level of the water. Here an orifice will be there which is at 5 meter below the surface. Now here the volume of the water escaping from the orifice they are asking. How much volume is going to be escaping? Means here we can take volume of the liquid which is coming outside is nothing but V equal to, you can take as according to the equation of continuity, area into its velocity you are taking. It's A into here with what velocity the fluid is coming outside, in this square root of 2gh you can take. Area it's given as 1 millimeter square, you have to convert into meter square. It becomes 1 millimeter equals to, you have to take as 10 power minus 3 meter. 1 millimeter square, in the sense it becomes 10 power minus 6 into square root of 2 into g, in the sense here 10 you can take. H value it's given as 5 meter above the orifice into 5 you can take. Here when you are simplifying this one, here 2 5s are 10, 10 10s are 100, root over 100 means 10, you will be getting 10 power minus 6 into 10 you can get. So the answer will be volume of the fluid which is escaping from the orifice is V equal to, you can take as 10 power minus 5 meter cube. This will be the correct answer. Look at the next question. A large vessel open at the top contains a non-viscous liquid of specific gravity is given as 0.8 is given. So if the hole is made at a depth of 5 meter from the free surface, now the question, the velocity of the flux they are asking. Here it's given as a large vessel is given, open at the top, contains non-viscous liquid of specific gravity. If the hole is made at a depth of 5 meter from the free surface, here you are keeping a hole which is at a depth of, here it's given as 5 meter from the free surface. This is the free surface, and here you are keeping at a distance 5 meter this orifice. The velocity of the flux they are asking. So with what velocity the liquid is going to be coming outside? It's a direct formula, student. According to speed of efflux concept, so velocity, with what velocity the fluid is coming outside, in the sense here this is a formula, square root of 2gh, 2 into g value you can take as 10, h is nothing but height above the orifice is given as 5. Then so here we will be getting as velocity, in the sense here 2 5s are 10, 10 10s are 100, square root of 100 means it will be 10 will be getting. So this will be the 10 meter per second will be the correct answer. Now look at the next question. A vessel filled with the water stands on a table. In its side, the vessel has a small orifice arranged at a distance 25 centimeter from the bottom of the vessel. Here it's given, a vessel is given, stands on a table. It's filled with the water and it stands on a table is given. From the bottom, here you are going to be arranging at a distance 25 centimeter from the bottom of the vessel and at a distance 16 centimeter above from the level of the water, which is kept constant. Now the horizontal distance from the orifice at which the jet of the water falls on the table is, here it's given as orifice you are keeping, and this will be at height is given, and here orifice you are keeping at this height. Now the liquid is going to be coming outside, and suppose here this is h you are taking, this height you are taking as h, and this will be at a height small h you are taking, and this will be the range you are taking. See here, it's given clearly the horizontal distance from the orifice at which the jet water falls on the table. This range they are asking, right? This range they are asking. Range, what the formula will be getting in this sense? Here we can take it as range is nothing but distance. Distance is nothing but you can take as speed of flux into time of descent you can talk. So with what speed it's coming outside in this sense, here you can take as square root of 2gh is the total height you can take, into you can get it as time of descent is nothing but here you can take as 2h by g you can take. Now here root g gets cancelled, then here we'll be getting as 2 2s are 4, then here we'll be writing as 2 2s are 4 into capital H into small h you are taking. So here the range which is nothing but 4 into capital H is nothing but here 25 centimeter from the bottom of the vessel. The vessel has a small orifice arranged at a distance 25 centimeter from the bottom of the vessel. So from the bottom of the vessel at a distance 25 centimeter it's given. This is the height h, and here you have to substitute that value. 25 centimeter means 10 power minus 2. The small h value will be getting as 16 centimeter. So 16 into 10 power minus 2 you can take. Now you have to calculate these values. Then R value will be getting as 4 into 25 is 100. This 100 and 10 power minus 2 gets cancelled. Square root of 16 means 4 will be getting into 10 power minus 1 will be getting. 4 into 10 power minus 1 in the sense here will be getting as 0.4 meters. So this is the range value you are getting, 0.4 meters. So second one is the correct answer. Now look at the next question. A tank with a vertical wall is mounted so that its base is at a height is given as h above the horizontal ground. A tank with a vertical wall is mounted so that its base is at a height is given. Tank you are placing, and of course it's filled with the liquid you can take here mounted so that its base is at a height h is given. So this base will be, this is the base you can take, it is about the height is given as capital H you are getting. Now a hole it is punched in the side wall of the tank at a depth x. Hole you are going to be placing here at a depth it's given as some x distance it's given. This is about x distance you can take below the water surface. To have the maximum range of the emerging stream, the value of x they are asking. Maximum value of the range nothing but here you can get it as. So now here the liquid level is going to be falling down like this. The fluid is going to be coming outside. With what velocity the liquid is going to be coming outside in the sense, here you can get it as v equal to the speed of flux will be getting a square root of 2gx. Now time of descent t equals to in what time interval it's falling down in the sense, this is the height we required, this is the height, this height which is nothing but capital H plus you can take as this is the height of the water you can take as small h you can take h plus h minus x you can take. Now this is the time value you will be getting as 2 into square root of h by g. H is nothing but h plus small h minus x by g you can do. This is the time of descent you will be getting. Therefore range is nothing but here you can take as speed. Range is nothing but distance. Horizontal distance will be getting r value. R equals will be getting as speed into you can take as time of descent, speed of flux into time. V you know here will be getting as 2gx into time of descent will be getting as 2 into capital H plus h minus x by g are getting, and here root g gets cancelled inside the root. Now here when you are taking 2 into x into 2 into you can take as capital H plus h minus x you can talk. Then together if you are taking square root of 4 you will be getting as 2 into here you can take as capital H x into h plus h minus x you can talk. Now here to get the range should be maximum, for R should be maximum, for R should be maximum, you can take dr by dx value, you can make it as 0. You just do the differentiation on both sides. When you are doing differentiation, dr by, this is R value, dr by dx, which will be equal to, this is here we will be getting as 1 root x. Root x differentiation will be 1 by 2 root x will be getting. So here we will be getting as, this is, you just multiply h into x plus hx minus x square. Again you have to do the differentiation of this function again. This is h plus small h, dx by dx will be getting as 1 will be getting, minus d by dx of x square value will be getting as 2x will be getting. And here this is a 2 you have to substitute. Now here when you are you are making this one as 0, then together you are taking is h plus small h minus 2x which will be equal to 0. Then x value, x is nothing but you can write it as capital H plus small h by 2 you are getting. So here this is the answer. Look at the next question. The level of the water in a vessel falls from height 64 centimeter to 36 centimeter in 5 minutes is given. As the water flows through a hole in its bottom, what further time is required for water level to fall from 36 centimeter to 16 centimeter? So here a tank is given and you are decreasing the water level, and here this is an orifice you can take. At the bottom you will be having an orifice, and here initially the liquid will be at a height h you will be taking, and this will be the height of the water level. Now you are decreasing the water level up to this height. This is the height you can take as h dash you can take from the ground. Then time to decrease the water level, the formula will be getting as a by a naught into 2 by g under root over h minus h dash you are getting. Capital A is nothing but area of the surface will be getting. Small a is a naught is nothing but area of the orifice will be getting. In the first case here the time value is given. That means here time is directly proportional to, you can take as h you can take. So the level of the water in the vessel falls from a height 64 centimeter to 36 centimeter. 64 centimeter to 36 centimeter. That means T is directly proportional to, you can take as root over h minus h dash you can take. That means T1 by T2 which will be equal to, this is root h minus root h dash you can take by second value you can take, this is h minus h dash you can take. This is the first case and this will be the second case you can take, which will be equal to initial height will be 64 root 64 minus root 36 by, you can write it as from 36 centimeters to, it is going to be falling from to 16 centimeter. Now you have to simplify this one. T1 by T2. T1 already it's given as 5 minutes is given. T2 value we need to calculate, which will be equivalent to, this is 8 minus 6 you will be getting as 2 will be getting. This is 6 minus 4 will be getting as 2 will be getting. So 2 gets cancelled. Again the time to decrease from 36 to 16 centimeters also will be getting as T2 value will be 5 minutes you are getting. So this will be the correct answer. Now look at the next question. A water barrel having a water up to a depth is given as T is placed on the table of height is given as h. A small hole is made on the wall of the barrel at its bottom. Here a water barrel is given like this. It is here having a water up to a depth is given as D. This is the depth of the water barrel is given. Now a small hole is made on the wall on the barrel at its bottom. Here you are placing a hole at the bottom like this. If the stream of the water coming out of the hole falls on the ground at a horizontal distance or from the barrel, Then the value of d they're asking. Here it's going to be coming outside like this. Here it is at certain height you can take. This height we don't know. Let us take as h. Let us take as h you can take. A water barrel having water up to a depth d is placed on the table. So here this is a table you are placing, which is at height is given as h height is given. Then here this is the range. This is the range of the fluid we will be getting. Now here range, what the formula will be getting, R equals to, you can take as speed of flux into, you can take as time of descent. Then R equal to, here we will be getting a speed of flux is nothing but 2 into G into H. H is nothing but here V equal to, will be getting a square root of 2GH. H is nothing but height above the orifice, that is nothing but D is the depth is given, into time of descent is nothing but here it is at from what height it is falling is 2h by g you can take. So here gg gets cancelled. Then when you are squaring on both sides, r square equal to, here you will be getting as 2 2s are 4 into d into h you will be getting. Then here they are asking d value, depth they are asking, d is nothing but you can write it as r square by 4h you are getting. R square by 4h. This will be the correct answer.